So starting part 2 of the 1.2 lecture, the next example, what we're concerned about with the square root is ending up with something that's negative under the radical. So we want to make sure that what's under the radical, x plus 4, pull that out, is greater than or equal to 0, because I can take the square root of positive numbers and the square root of 0. So just solving this simply would be x's that are greater than or equal to negative 4. So that's my domain. Domain can also be written with the square bracket around negative 4 and go to positive infinity. If we looked at a graph, we can also see that it starts 1, 2, 3, 4 to the left. So the square root graph is going to look something like this. So you can definitely see that starting at negative 4 and going all the way out to the right. Example 3 is just a set of points, a relation, and if somebody asked you to write down the domain, we're simply going to write down the x and y, the x value, so negative 5, 9, 6, and 4. All right, so we're going to have you pause the video again here right away. There's a DIY, there's 2 on this page and 2 on the next page. So pause the video now. So with example 4, the x squared minus 9, again, you could pull this off to the side right here and set the bottom, which is x squared minus 9, set it equal to 0, solve it, subtract or add the 9 to both sides. And then remember, when you take the square root here, you want to allow for the positive or negative right there, positive or negative, because you took away an even power. So what this is telling us is that 3 and negative 3 are these imaginary vertical asymptotes. So the other thing you want to remember is that when you go to type this into our calculator, you want to go to y equals, and you want to type in 1 divided by parentheses x squared minus 9. So that will give you this graph that looks something like this. And then we're going to say something to the effect that all real numbers except x is equal to negative 3 and 3. You cannot use those two. So you write the not equals to for those. And then this example is again a square root. So we would start by doing our set it equal to 0 thing, greater than or equal to 0. And when you solve that, the algebraic expression is x greater than or equal to 1/2. 1/2 with the square bracket to infinity is another way to write the domain. And the issue that you'll find if you try to graph it and only solve with the calculator is, where does this thing hit? It's really tough to see on the graph, and so that's why this algebraic solution is a good one to use. Hello.